Okay, so last page. So first of all, again, you can think about this problem right here. You don't have to rewrite it, but it is something that you just sort of need to train your brain to think like. 1/3 times 1 over x minus 2e to the x dx. Okay, so I just kind of pulled these apart because I'm hoping that you can see, based on the example that we just did, what's the integral of this? Yeah. So this is going to be equal to 1/3 times the natural log of the absolute value of x. Okay, minus. What's the derivative of e to the x? So then what's the integral of e to the x? Oh, e to the x. So then what's my answer for this part? 2e to the x and then plus c. Yes. Okay, questions on D? You guys good? Okay, so now you actually need to go back and start thinking about your trig derivatives. Okay? So if I asked you, what do you take the derivative of to get cosine? Sine. So that's the integral. We're just going back, like on the unit circle. Remember, you would ask yourself, what angle do I take the sine of to get 1/2? You can go back to the angle. It's the same idea.
But it's not negative.
I'm taking, okay, when I take the derivative of sine, so let's say this was sine, and I said, what do I take the derivative of to get sine? It would be negative cosine. Right? Ha, I saw the bulb. Okay. So this is equal to the sine of t. True? All right, now you need to ask yourself, what do I take the derivative of to get cosecant cotangent? The other one. Okay, let's look. Let's look. So cosecant cotangent is negative cosecant. Okay, so you have to just, it's okay, because we have to train our brains. So that means if this right here is negative cotangent, what is this sign in here?
Plus.
Ah, plus. Plus C. Cotangent T. Oh, lie. Cosecant. Ah, dagger.
That's on YouTube, so.
That's fine.
Is it?
It is.
I think I might unsubscribe. I might unsubscribe, not gonna lie.
Cosecant. There you go. Is that better? Okay, it's going to have to be. Jasmine. Now that's on YouTube. Okay. So far we have talked about indefinite integrals, where we were just identifying the general integral, and we did not have our c value. So now what we're going to do is actually find the c value. And in order to find that, we have to be given a point on the graph. We have to have something to find c. So we're actually going to integrate just as we were, but now we are given a more important piece of information, and it's right here. So these are known as initial value problems. So if it says, if the directions say solve the initial value problem, that means you got to find c. You cannot just write your answer as plus c. This is a very specific answer. Okay? So before I do anything, I actually need to rewrite this. All right? So we have dy dx is equal to x over x to the 1/2 power plus 1 over x to the 1/2 power. Okay, all I did was just rewrite it so that you could see it. So when your base is the same and you're dividing, what do you do to your exponents? You do subtract. So this becomes x to the 1/2 because it's 2 over 2 minus 1 over 2. True? Plus x to the negative 1/2. Everybody good so far? Okay, in order for us to integrate, this dx needs to be over here. So we have dy is equal to the quantity of x to the 1/2 plus x to the negative 1/2 dx. So this is indicating that this is the derivative. True? Okay. We are integrating essentially both sides. If the integral of dx is x, what's the integral of dy? Okay, so this is going to say y equals, we are integrating. Okay, so you're adding 2 over 2. So my new exponent is what? I heard it. I get a little 3 over 2. So what's my coefficient?
2.
2 over 3. It's a reciprocal. Yes. It's 2/3 x to the 3/2. Plus I'm adding 2 over 2 to this one, so that's 1/2. So what's the coefficient for this?
You mean the exponent or 1/2?
Yes. The exponent is,
1/2.
so the coefficient is true. Did I say it backwards? Okay, thank you. And then I do still have plus c. True? This is just general. So we're good up to this point. This is what we've been doing. Now what we're going to do is actually use this. Is this x or y right here? Ooh, this is x. What is this? This is y. So what we're saying is that when we plug in our x and our y value, 0 is equal to 2/3 times 1 to the 3/2 plus 2 times 1 to the 1/2, whoops, plus c. Okay, 1 is easy, but I just want to show you the substitution. So this now is 0 is equal to 2/3 plus 2 plus c. What is that, 6/3? So then this is 8/3. Subtract c is equal to negative 8/3. Okay, before I continue, I just want to make sure that everybody understands where that came from. Okay, so we're going to go back to this. This is my general equation. I want the specific equation, which means I'm going to take this and put it in here for c. So when I write my answer is y of x is equal to 2/3 x to the 3/2 plus 2x to the 1/2 minus 8/3. So this here is general. This is the initial value, specific. Okay, questions on how we got anything before we go to the next problem? Yes, Zach?
I was wondering if we could turn the fraction exponents into radicals.
You can, but it's not necessary. Most likely in the answers that you'll see, they'll all be rational exponents. It just becomes, part of the reason that you leave it as a rational exponent is it looks more elegant. You know, it's because all the radicals, it just takes up so much space. So a lot of times writing them as rational exponents, it just looks nicer. So is it wrong if you do as a free response? No. But any other time when you see it, it's going to be like this. Especially, too, if you have a really long polynomial or function. So it's really up to you. Okay, any other questions before we continue? Okay, let's take a look at this next one here. So here is our function that we are going to integrate. Here is our point on the graph. So let's start. Do I need to simplify anything before I begin my integration process? Kind of like, and I'm referring to what we just did in the previous problem, like the dividing or simplifying. Yes, no? Meaning, if I asked you over here, could you integrate this as is right now? It's a division problem, so no, we had to do some simplifying. Could I integrate sine? Can I integrate 1? Okay, so I don't really have to do a whole lot, right? We just need to rewrite this as dy is equal to the integral of the sine of t plus 1 dt. I just multiplied by dt and put that little integration sign in there. Okay, so when we're integrating, what's the integral of dy? Y equals, what am I taking the derivative of to get negative cosine? Of t plus what? Well, t, yeah, variable. And then I have plus c. Everybody good? That one was a lot easier than the previous, right? Okay, so we know that our y value is equal to what? It is 1/2. Is equal to negative cosine of pi over 3 plus pi over 3 plus c. Okay, what's cosine of pi over 3? It is 1/2. So this is 1/2 is equal to negative 1/2 plus pi over 3 plus c. So when I move this over here, I get what? Oh, I get 1. Okay, right? And then I need to move this over. So isn't this 1 minus pi over 3 is equal to c? Okay, because we're not using a calculator, this is a decimal value of some kind, right? So we're just going to leave it. We've got y of t is equal to, so I'm going back up here. Let me use my highlighter again. Going right here. Negative cosine of t plus t, and then I'm just going to write plus the quantity of 1 minus pi over 3. And I just put it in parentheses. Don't know, negative, positive, I just leave it in there. It's fine. Okay, so this is my final answer. Okay, questions? All right. So here it says find an equation of the curve that satisfies the given conditions at each point xy on the curve. The slope is the quantity of x plus 1 squared, and the curve passes through the given point. All right, so first of all, we want an equation. So just like we had before, it didn't say it in this manner, but we were finding an equation, right? Y of t is equal to, where is it? Y of t is equal to this. Y of t is equal to this. This is an equation. So that's what they're looking for. Satisfies the given conditions. So what we have is the slope is x plus 1 squared and passes through this given point. What does that mean? The slope is? Oh, it's the derivative. Huh. And then when you're given a point, what do they want you to find? Oh, this is going to help us find c. Okay. So they're saying that f prime of x is equal to the quantity of x plus 1 squared. So if I need to find the equation, we know we're going to integrate. Can I integrate this? Not as is right now. Eventually you will know how to do this, but not right now. So that means I have f prime of x is equal to x squared plus 2x plus 1. How'd I get that? Thank you. Okay. So now, this is my first step. We're going to integrate. So when I integrate x squared plus 2x plus 1 dx, let's go up here. Okay, I'm going to write this as capital F of x, the antiderivative, right, is equal to, what's the first term when you integrate? Say it a little bit louder. Not 1/2. 1/3. Yep. So remember, you add the 1 first, and then you multiply by the reciprocal of that exponent. So it's 1/3 x cubed plus what? I heard it. X squared plus check. Okay, everybody good so far? So this is the general form of the equation. General form. So we're going to find this right here. Okay? So now, in the second step, we're going to find c. So this essentially is my y value, true? So what goes there? I heard it. 8 is equal to. And then for every x value, I'm plugging in -2. Agree? So I'm just going to do the substitution. We have 1/3 -2 cubed plus -2 squared minus 2 plus c. Okay, so we have 8 is equal to -8/3. This is going to be plus 4, but it looks like I'm going to need a common denominator. So what is that, 12/3? Minus 2, so what is that, 6/3? Thank you. Plus c. Should I change this one?
Yeah.
What is this? 24/3. Okay, this kind of helps me a little bit. Actually, a lot. Let's see. This is 4/3, -2/3. So when I add this over here, what do I get? 26/3. Okay, so now I have c. I'm going to go back here and plug it in. So then our equation is f of x is equal to 1/3 x cubed plus x squared plus x plus 26/3. No one ever said that constant had to be pretty. Whoops. Okay, questions before we do the last two? We're doing good. 5 minutes. 5 minutes. Max. Okay. So if you go back to that list on that first page, we do not have identity or rules that relate to these. Okay. Cotangent squared. So I need to figure out how I can maybe make a substitution. So a lot of times what you need to go back to, which I know some of you don't like, you got to go back to your Pythagorean identities. I saw that face already. 1, 2, 3. Okay. So just like this. Okay. So just. Okay. Do you remember the hexagon?
Yeah, I remember.
I've never seen this game before. Yeah.
He just said it was stupid.
Sorry, Miss Faven, not that specific one. I remember it.
Okay, so all I do, when instead of drawing an entire hexagon, when I am literally sitting down to take one of the tests, this is what I draw, because these are the main triangles that you need to focus on. So this is sine squared, cosine squared, cotangent squared, cosecant squared, secant squared, and this is tangent squared. So not everyone learned it exactly the same, but all the identities are the same because what's in the middle? A 1. So for those of you that have forgotten, I'll move my hand in just a second if you didn't get it all. Hang on 1 second. This is sine squared plus cosine squared is 1. That's the most common one that you guys know, right? Yes? Okay. Then this triangle right here, 1 plus cotangent squared is cosecant squared. Well, here's my cotangent squared. Okay, I'll move.
Wait, how do you know that which one is the two tops of the triangle are the things you add in the bottom?
Across the triangle, like, so you basically, it's like you take the triangle out of the hexagon exactly as you see it. So if you're looking up here for 1 second, see this one right here? I'm going to cover these two. I'm taking this triangle out. So it's I know you can't read it. It says tangent squared. But it's tangent squared plus 1 is equal to secant squared. So now I can write the identity. So if I have 1 plus cotangent squared is equal to cosecant squared, okay, this is just to help me because I need to make a substitution. I'm going to go back to these rules in just a second. Let me see if I've got something with a cosecant. Can I integrate? Oh, look at this. Cosecant. I can integrate cosecant squared. Yeah, I'm a little too excited. It's going to be okay. Yeah. Okay? So if I solve this for cotangent squared, I can make the substitution, meaning cotangent squared of theta in this case is equal to cosecant squared theta minus 1. Does everyone see what I just did? Okay, so now I'm going to make the substitution. So I'm going to rewrite this as the integral of the cosecant squared theta minus 1 d theta. So now you're integrating. This is that subtraction rule. And yes, I got super excited about this rule right here. So the integral of cosecant squared is negative cotangent, right? So I'm going to integrate. This is negative cotangent of theta. And then this is going to be minus what? Theta. And then we have plus c. And this is basically equal to f of theta. So that way if you write the correct notation. So why am I doing this problem? It's to show you that sometimes you have to make a substitution before you can integrate. So this is me thinking outside the box, okay? Here's the box. This is me thinking outside the box. This is what I'm about to do. No, you've never seen this identity before, this one. Okay. So I need to pull this apart somehow. So what we've got is the integral. Yes, my brain, it was like on fire. Smoke. That's smoke. Yes. Sine theta over cosine theta times 1 over the cosine of theta d theta. So I'm just pulling this apart because how can I rewrite this? Tangent. And what about this one? Secant. So let me look here. I'll move in just a second. Nothing interesting going on here. Goodbye. Okay, so you guys said tangent, secant. Integral of tangent, secant. Integral of... oh, hello. Yes, excited. Right here. I know. Thank you. That's why my brain was on fire. Okay, so you have the integral of the tangent of theta times the secant of theta, d theta, and then we just saw that it's a rule, so the integral of that is what? Secant of theta plus c is equal to f of theta. Done. But this is why it's important that you know those integrals. Okay, so you need to practice those because you need to recognize. Because you're not going to be able to flip back and forth when you're doing this on a test. Smoke.